In this video, we will be solving two sets of nonlinear equations using Newton's method. And so let's get started. So these are our two equations. So the first step that I'm going to do is this. F matrix x1, x2 below is equal to f1, x1, comma, x2. Because I have an x1 and an x2. Likewise, f2 parentheses x1 comma x2 bracket. And this will correspond to this. What I'm doing right now is essentially just organizing this problem. Plus 2x squared minus 25. And now this one. So 2x1 squared minus x2 minus 15. Next, we will get the Jacobian. So we say J is equal to matrix again, but now I will take the derivative of x1, x2 for each of these two equations. And I'll show you what I mean. So I have 3x1 squared, right? I don't have x1 anywhere else in this first line. So I will take the derivative of this number, of this, and I will get 6x1. Next, I will do x2. I only have one x2, just this in this first line. Again, I will take the derivative of this. So I would get 4x2. Now I will do the bottom row. So I only have one x1, just this. Take the derivative, I would get 4x1. Next, I take the derivative of x2. I don't have any other x2, just this. Take the derivative, I would get -1. Next, in this given problem statement, we said the initial value for x1 and x2 was 1, 1. And so now I will apply that. So say j parentheses 1, 1 is equal to. So now I essentially put 1 for x1 and put 1 for x2. So I would get 6, 4, 4, and -1. And this is just another fact. This number corresponds to A, this as B, this is as C, and this is as D. And we will need to apply this next. So next we will get J inverse, and that's going to equal to 1 divided by. We do 6 times -1, this diagonal, 6 times -1, this diagonal here, minus parentheses, this diagonal. So 4 times 4. And this is where we need to kind of mess around with this matrix. So instead of A, B, C, D, it's going to be D, -B, -C, and then A. This is a rule. So D, -B, -C, A. So I'm just going to replace it with what we will have next. So D was -1. So we put -1. C is the just negative of it, so -4. B, negative of it, so -4. And then D is now A. And so A was 6. So let me repeat this again. So for this step, I swap A and D, meaning D is now A and A is now D. And then for B and C, we just flip the sign. So if it was positive, it's now negative. If it was negative, it would be positive. And so 1 divided by this is 1 over -22 times this matrix. So -1, -4, -4, and 6. We will be using this shortly, but let me mark this because this is very important. The next step that I will do is apply 1, 1 to each of these two equations, meaning f1 parentheses 1, 1, and I would get 3 parentheses 1 squared plus 2 parentheses 1 squared minus 25, and this would equal -20. Next I do f2 parentheses 1, 1, and do the same idea. 2 parentheses 1 squared minus 1 minus 15. And I would get negative 14. The next step is to actually do one cycle. In this problem, I said we would do 2 cycles. So we're very close to finishing one cycle. And this is what we would get. So I can write first cycle. And that's going to be the initial 1 comma 1. So 1, 1 like this. Minus parentheses this right here. So negative 1 over 22 times this matrix. So negative 1, negative 4, negative 4, and 6 like this times this. So it's going to be 20, negative 14. So this is a matrix, this is parentheses, matrix, matrix. And so now I'll just type this right here into a calculator. So now I will be using my TI Nspire CX cost. So I will hit this icon, then this icon. We had 1, 1 minus parentheses minus 1 divided by 22 times, we want a 2 by 2 matrix. We had negative 1, negative 4, negative 4, and 6 times this icon, then this. Then we had negative 20 and negative 14. Hit enter. This is the exact value, but we can also do an approximation. So control enter, and this is the approximation. But since we want to do 2 cycles, I will be more accurate for this first cycle and keep the fraction. So in this first cycle, x1 is 49 over 11 and x2 is 9 over 11. And so we get 49 over 11 and 9 over 11. This is the first cycle. So first cycle. We want to do 2 cycles to be more accurate. Now the first step that we could do for this part is write f1. Last time we did 1 comma 1 because that is what we were initially given. But now we have 1 cycle and we had 49 over 11 and 9 over 11. So we will be using that information, comma 9 over 11. And this is going to equal, we just apply it to these 2 equations. So 3 parentheses 49 over 11 squared plus 2 parentheses 9 over 11 squared minus 25, and we would get 4,340 over 121. Next, same idea, f2 parentheses 49 over 11 comma 9 over 11 is equal to this equation here. So 2 parentheses 49 over 11 squared minus 9 over 11 minus 15, and this is going to equal 2888 over 121. And now after this step, it's going to be exactly like what we did for the first cycle. So if you want, you can pause the video here and attempt to solve the problem. And so let's do that. So the next step that we will do is the Jacobian. So j is equal to, same idea, the derivative of x1 for this, which is 6x1. I'm taking the derivative of just x1. So I would get 6x1. Next, take the derivative of x2. So I get 4x2. Next, I will do the bottom equation. So just the derivative of x1. So I get 4x1. Just the derivative of x2. So I get negative 1. And now in the last problem, we did 1 comma 1. But now we use the 49 over 11 and 9 over 11. So x1 is 49 over 11 and x2 is 9 over 11. So what I'm going to do here is plug in 49 over 11 for x1 and 9 over 11 for x2. This would give us, we would get 294 over 11 and 196 over 11, 36 over 11, and negative 1. But now we also need to get the inverse, so we say J inverse is equal to 1 over parentheses, this diagonal here. So we had negative 1 times 294 over 11. This diagonal here minus parentheses, this diagonal. So that's 196 over 11 times 36 over 11. This will be multiplied by the new matrix. So where we flip A and D, so this is now A, negative 1, and this is now D, 294 over 11, and then these two become the opposite sign, meaning negative 196 over 11 and negative 36 over 11. So we would get 1 divided by this would be negative 121 divided by 10290 times this matrix. So negative 1, negative 196 over 11, negative 36 over 11, 294 over 11. After that, we can say now our second cycle. And that's going to equal our first cycle. We got these two numbers, and so I will write it down here. 49 over 11, and in the bottom 9 over 11 minus parentheses this negative 121 10290 like this times this matrix negative 1 negative 196 over 11 negative 36 over 11 294 over 11. Then we'll multiply that by these two numbers when we did F1 where we changed the new cycle. So these two numbers here. So we write that down. 4340 121 and 2888 divided by 121. Now I'll use my calculator to get the final answer for the second cycle. So we hit this icon. We want this. We had 49 over 11 and we had 9 over 11 minus parentheses minus 121 divided by 10290 times, we had now a 2 by 2 matrix. So negative 1, negative 36 over 11, negative 196 over 11, 294 over 11 times, now we want this matrix here, and this is going to be 4340 divided by 121, bottom 2888 divided by 121. We hit enter and we get approximation since this is the final cycle. Control enter. So x1 would be 3.114 and x2 would be 0.804 after 2 cycles. And that's all we need to do for this problem.